Hello students, welcome back after a long gap. Today we will be discussing about the D and A block elements of class 12. So first of all, you know that what are called the D block elements. D block elements means those elements in which the last electron enter into the inner D subshell. That is known as the D block elements. Now, first today we will be discussing about the electronic configuration of the D block element. The general electronic configuration of the D block element is that the outermost electronic configuration, it will be n-1, D1 to 10 and ns1 to 2. So, if we consider that each D block element has an inner core of electrons with the noble gas electronic configuration. In case all the transition series, that is the 3D, 4D and 5D, with increase in atomic number, electron gets added into the n-1 D subshell. n-1 D subshell. Now, if we consider the electronic configuration of the chromium, you know that chromium has exceptional electronic configuration of 3D5 4s1. That is the question. See, chromium 24, it should be that the argon 4s2 3D4, but instead of this it becomes 3D5 4s1 to give extra stability. Similarly, the electronic configuration of the copper also, there is an exception, all of you have read in class 11 also. Copper, it has the electronic configuration, actual electronic configuration argon 3D10 4s1. Now, most of the elements have 2 electrons in their outermost orbital, that is the ns orbital. Only in case of the certain elements like chromium, copper, then Nb, Mo, silver, platinum, etc., they are only 1 electron in the ns orbital. However, there are no electron in the ns orbital of the Pd or palladium. In lanthanum, 1 electron enters the 5d orbital before commencement of the filling of a 4f orbital, though the energy associated with the 5d orbital is greater than the 4f orbital. That is exception to the Abbaugh rule. Now, if we consider that the transition element, what are called the transition element? Transition elements or the transition metal means those elements in which they have the incompletely filled D subshell in their ground state or in any of their stable oxidation state. That is known as the transition element. That is the modern definition of transition element or transition metals. Now, once again I am just discussing here what is called the transition metals. Those metals or those elements in which the last electron have the incompletely filled 3D subshell, as well as the outermost shell also is incompletely filled, but also in another cases maybe there that if the element have incompletely filled D subshell in their any stable oxidation state, that is also known as the transition elements. That's why you see the copper, silver and gold are known as the transition metals, because see, copper electronic configuration shows argon 3d10 4s1. In the ground state 3d orbital is completely filled, but you know that one of the stable oxidation state of the copper is the copper 2+. So in this case the electronic configuration what is coming 3d9. That means it becomes the incompletely filled. That's why copper is considered the transition element. But if you consider the zinc is not considered as the transition element true sense, because you see the zinc, it has the electronic configuration argon 4s2 3d10. Now if we consider the stable oxidation state of the zinc, that also will have the electronic configuration argon 3d10, where see in both the cases the d orbital is completely filled. So as it has the completely filled, so this is not considered as the true transition element, but as it actually bears some property of the transition elements, so in the discussion of the transition metals, this also has to be considered, but these are not transition. Zinc is not a true transition elements or in transition element in the true sense. Now if we consider the general characteristics of the transition elements, Nearly all transition elements have typical metallic properties like thermal and electrical conductivity. and high tensile strength, malleability, ductility, metallic luster, etc. Except mercury, which is a liquid at room temperature, all other transition elements have a typical metallic structure. They have high melting and boiling points, have high enthalpies of vaporization, and these properties are related to the strength of the metallic bond. They have high densities relative to the metal of group 1 and 2. Now, obviously, they exhibit the variable oxidation state, region we will be discussing later. They usually form colored complexes and they have a good tendency to form complex compound. Now, next one we will be discussing here, that is the general trends in properties of transition element. One first property we will be reading today, that is the metallic character. Except mercury, all other transition elements exhibit characteristic metallic properties. They are hard, lustrous and the malleable, ductile, and have high tensile strength, high thermal and electrical conductivity. Okay, now see why they show this type of metallic character. Transition metals have 1 or 2 electrons in their outermost shell. So these electrons used to form the metallic bonds. Unpaired electrons of the n-1 d orbitals are also involved in the formation of metallic bonds. Thus both ns and the n-1 d electrons participate in metallic bonding. So obviously the strength of metallic bond increases as the number of unpaired electron in the d orbital of the corresponding metal also increases. Okay, so for this reason, chromium, molybdenum and the tungsten having maximum number of unpaired d electrons are very hard metals and have low volatility. And the elements zinc, cadmium and mercury do not have any unpaired electron. Therefore, these are not very hard, and as a matter of fact, mercury is a liquid. So in this video today, up to this we have discussed. In the next video we will be giving more information regarding the DNA block elements. And that's all. Thank you.